Welcome to Study Loop.
This is chapter 37, problem number 30. We're given an electron, and due to an electric field, there is the force acting on this electron, and the magnitude of 5 times 10 to the power negative 15 newtons. And we know the mass of the electron, 9.11 times 10 to the power negative 31 kilograms. So we were asked to calculate the acceleration on this electron if the speed of this electron is 1 kilometer per second, which is 1,000 meters per second, which is not a relativistic speed. So Newtonian mechanics is going to be sufficient enough, and times A equals the force. If you're after the acceleration, then if we divide both sides by the mass, m's are going to cancel. The acceleration is going to be equal to force divided by the mass. Force is 5 times 10 to the power negative 15 newtons. The mass is 9.11 times 10 to the power negative 31 kilograms. In this case, our acceleration is going to be 5.49 times 10 to the power 15 meters per second squared. It's a very high acceleration. Part B, find acceleration if, now we're dealing with the relativistic speeds, 2.5 times 10 to the power 8 meters per second. And there is an important part to this problem where it says F is parallel with respect to the velocity vector, because this is going to change everything. So I recommend you to go back and revisit on your textbook the equation 37.32. In that equation, it's going to be specified the force, relativistic force this time. If the force is parallel with respect to your velocity vector, you're taking the cube of the gamma factor times m times a. So again, we're after the acceleration, so I'm going to divide both sides by gamma cubed times m, gamma cubed times m. So acceleration is going to be f over gamma cubed times m. F over m we already calculated here. So remember what gamma was. Gamma is 1 over square root of 1 minus b squared over c squared. So if I take the inverse of it, since it's in denominator, I'm going to flip this ratio right on the right hand side. So what we're going to have is 1 minus b squared over c squared cubed f over m. So square root of 1 minus 2.5 times 10 to the power 8 squared divided by 3 times 10 to the power 8 squared times f over m is already 5.49 times 10 to the power 15 meters per second square. If we calculate this, we're going to find the acceleration to be 9.27 times 10 to the power 14 meters per second squared.